Hello, everybody. I think that everybody can hear me. Thank you so much. I'm so happy and excited to be here. I would like first to thank all the Adapters team that I have been able to meet, first in Berlin and after in Pisa a few weeks ago. So my name is Antoine, and I'm currently cycling around Europe, 10,000 kilometer bike trip to understand the whole hydrogen value chain. I have been on the road since now 8 months and met more than 200 players. And yeah, I'm really excited about hydrogen. And what excites me the most is all the use case that you can have with hydrogen. And today, we're going to see 3 of those use cases: in water, in the snow, and in the air. So let's start by presenting first Xiaoxiao, who is a researcher in propulsion engineer. She obtained her PhD in low-emission combustor in 2018, and her research is focused on the development and simulation of gas turbine low-emission combustion technologies. So let's see if she's here. Excuse me. First, we're going to introduce Markus. So Markus is a researcher and a project manager at Hycenta Research. So he obtained his PhD degree in technical science, mechanical engineer, and he coordinates multiple projects. And the project that we are going to speak today, it's a snow application.
So, okay. So hello from my side. I'm not sure. I'm on stage. Can you give me a sign? I'm not sure that you can hear me. Yes, Markus. Okay. Yes, you are. Fine. Yeah. Hello to everybody. I'm sorry I had a short interruption in my connection, but I will start to introduce you to the project Hycenta. The project is a project where the winter tourism in Austria is decarbonized by PV powered electrolysis and hydrogen powered snowmobiles. Yes, and first of all, the Hycenta, what we're doing, we are an extra university a research institution. We are doing hydrogen projects since 2005, and in the whole field of hydrogen technologies, from the production, storage, every technology that is needed in the hydrogen technology field is researched and developed by us. And one project is of course this Hycenta project here. A short project overview. There are several partners within the project to do all the things that we want to do. The project duration is from 2017 to 2022. There is still 1 year left, as you can see. The total R&D costs in this project are 5.6 million euros, and funding in Austria is 2.6 million of euros. But the project itself now, I will skip this to not to be too long. The project itself is incorporated at the skiing region in the heart of Austria, I want to say, called Hinterstoder, in the region Hinterstoder. You can see here on the left side the hydrogen infrastructure, which is built up in on the mountain at 6,300 meters above sea level. The hydrogen infrastructure is powered by the PV panels. You can see here it's roughly 35 kilowatt peaks, making roughly 150 kilowatt electric hours a day, and which we are using to produce our hydrogen on the mountain. You can see here the station on the left side, the PV. Here the container where the electrolyzers are incorporated. There is also a compressor incorporated, which compresses the hydrogen up to 350 bar. And at the dispenser is here on this side to refuel our hydrogen-powered, fuel cell-powered snowmobile. The snowmobile itself is also developed within this project. You can see the development process and our stations and test rigs on Hycenta here, and was done within this consortium. Yeah, it was very short introduction. Thank you very much. And I will give back.
Thank you so much, Markus. Sorry for this delay. We are looking with technical issues. So next speaker, we're going to welcome Dr. Xiaoxiao Sun, who is a researcher in propulsion engineering. She obtained her PhD in low-emission combustor modeling in 2018, and now she mainly focuses on development and simulation of gas turbine low-emission combustion technology, and especially for hydrogen combustion. Welcome, Xiaoxiao.
Thank you, Anton. So, good afternoon. Thank you for attending my presentation. This will be a very short version of the introduction of the project, but I will give you a flavor of what we are trying to achieve in terms of, enabling hydrogen as aviation fuel for the aircraft. So we all know that for currently, civil aircraft employs gas turbine technologies, and in order to introduce hydrogen, there are two options. One is gaseous, one is liquid. But from a volume perspective, because it's quite significant a factor for an aircraft, we will opt for liquid hydrogen because it just saves you the space. So the Enable H2 project is a project that's trying to prove that switching from conventional hydrocarbon jet fuel to liquid hydrogen as an aviation fuel is feasible. Can I go to next slide? Yeah. So this project, it's based on a very ambitious target by Flightpath 2050. That's in year 2050, that the aviation industry needs to achieve a 90% of nitrogen oxide reduction and 75% of CO2 reduction compared to year 2000 technologies. This is extremely ambitious because of the fact that we are always trying to improve the efficiency of a gas turbine engine. In order to achieve that, because we want to save the fuel, in order to achieve that, we have to target very sort of critical conditions in terms of burning, when we're burning the fuel. And as far as we reach these critical conditions, we are generating a lot of heat, and this will lead to, for example, high production of NOx, or either we are trying to reduce CO2, that means, or we might achieve incomplete combustion. So this project aims to see if it's possible for hydrogen to achieve this target, because we know that there is no carbon content in hydrogen. So the only focus will be on NOx. So this project has a budget of about 4 million euros, and it involves a number of project partners and a large number of industrial advisory board members involving all the key stakeholders in the aviation industry. We have three main targets. That is to mature key enabling technologies for liquid hydrogen to be used. This includes the combustion technology in a gas turbine. So we want to replace the conventional kerosene combustor with a technology called micro-mix combustion, which is the focus of my research, because it is able to achieve potential of ultra low NOx, but also decarbonizing the emission level aviation industry. And also there is advantages in terms of liquid hydrogen when it turns into gaseous, we are absorbing a large number of heat, a large quantity of heat, and we can use this heat as a heat exchanger, trying to improve the engine cycle efficiency. And last but not least, we need to analyze if this switch to hydrogen is economically viable or feasible, and how much advantage we can take in terms of reduction in emission. So we are going to do analysis in terms of environment and risk, and also economical analysis. And apart from these, we also need to address the key challenges and skepticism around hydrogen. So is hydrogen safe? So everybody wants to answer that question. And we have a dedicated work package on looking at the aircraft and infrastructure safety for hydrogen. Apart from all these, in the end, we need to establish what is the roadmap to, realizing all of these very nice technologies and incorporating this into an aircraft that is, can be flying 2050. We all know that Airbus is now targeting 2035, which is very ambitious. So on the right, on the top, you can see it's sort of our view of how the transition to hydrogen will happen from kerosene. So we're going to continue to see kerosene for a long time because all the current aircraft employs kerosene as a fuel. But we are switching to biofuels or sustainable aviation fuels. And also there is room for example, natural gas or ammonia and so on. And there is also room for batteries that involves fuel cells, which also use hydrogen. And but still there is some disadvantages that we see that in terms of weight and battery technologies. So we see that liquid hydrogen, especially for the medium to long range aircraft, is going to dominate in the future for aviation. And you can see there are two sort of prototype of aircraft that we envisage in the future. One is the conventional turbine wing, where we place the huge tank of hydrogen above the aircraft. The other is a blended wing body, which is a more radical change of aircraft shape, let's say, or configuration, but a more efficient way of flying. And the key enabling technologies, as I said, the first one on the left, this is about engine cycle. So trying to come up with, for example, heat exchanger or other cooling technologies, trying to use hydrogen to cool all the components because we are burning and operating the whole gas turbine at an extremely high temperature. On the right, it's a shame that you don't see the animation, but this is, for example, a small prototype of how hydrogen combustion is happening in a very small space. So you can, the actual length of this flame is less than, let's say, 30 millimeter, which is just 3 centimeters. So it's extremely small when combined with the micro-mix combustion technology. So in terms of project partners, Cranfield is the coordinator, and we have Chalmers University looking at the engine cycle, the heat exchanger perspective. We have London South Bank University looking at the safety work package. We have Safran looking at not only aircraft and in terms of techno-economical risk assessment, but also the combustor technology with Cranfield. We have GKN also looking at heat exchanger and also aircraft configurations. And we also have support from, for example, European Hydrogen Association and Heathrow to looking at, production of hydrogen infrastructure for hydrogen at the airport. And at the end, we have a project management company, Arctic. And we also have a large number of members who are interested in this project as an advisory members, like all the stakeholders, Airbus, Rolls-Royce, MTU, and so on. And we also have industrial gas turbine manufacturers like Siemens. And this is because, all these technologies that's used in aviation, there is a way we transfer it to industrial gas turbines. And they are already using hydrogen, which is there will be good lessons that we could learn from for aviation. And we also have some legislation bodies like IATA and ICAO. And we have Clean Sky 2, which is essentially a funding body in the European that supports all the low emission technologies for aviation. And recently, we just had Flight Zero, which is in the UK, to support, to help us as well. So for my focus, as I said, it is on combustion technology, micro-mix combustion. And this type of technology, because of the some properties of hydrogen, it is extremely interesting to use hydrogen when combined with this technology. So when we do research, we start from a concept, trying to prove to people that, this technology can be used with hydrogen, and why it is advantageous compared to when using other conventional fuel with this type of technology. And then we move on to trying to tackle the manufacturing of this injector, for example. This is a very small prototype compared to conventional injectors, which is almost the same size as this plate here, but it only has one injector. Here you can see there are 50 injectors. So that's why we call it micro-mix. And apart from manufacturing it, and we also do simulations for it, to looking at how the flames look like with this injector. And as I said, these flames are extremely small, just 3 to 5 centimeters long. It's not like the large fireballs you usually see in combustors, but we just combine all of these small flames together, and they provide the same amount of energy. But each of them, they are very small flames. And as soon as we have some confidence in, when doing simulations, see, what it would look like, we move on to experiments, which we are actually currently doing now with some high pressure, high temperature rig that is trying to visualize how the flame look like, and also doing measurements on what is the emission level. And after we prove our concepts and getting measurements that we are confident that we're going to achieve low emission with hydrogen combustion, we move on to the combustor design, which is the bottom right picture. And that is a final goal, that in this project we produce a design that we think is feasible, and also trying to inform the project partner what will be the emission level of this type of combustor. I think that is all. If you have any questions.
Thank you so much for this presentation. We will come back here later on it. Last one, can we receive Tim, who is currently head of TRUST program, a multi-year initiative to reduce the climate impact caused by the maritime transport.
I switched on the mic, so I hope you guys can hear me. Hopefully also see me. Yeah, good afternoon, everybody. Thanks for being in this session. As Antoine introduced, my name is Tim. I work for Enviu, and at Enviu we have a division that is working on developing projects to help stimulate the energy transition on water, because we all know that the maritime industry is a very laggard industry when it comes to innovation. There's a lot of innovation, but small scale, and completely opposite to the aviation industry, where there are large centralized R&D budgets. So we have it as our mission to develop business models that can really help the transition. And we are developing business models where we develop cross-sectoral solutions with partners throughout the value chain. Because we believe if you only develop technical solutions, the hurdles in terms of financing and so on are that steep and that high that it's very difficult, to sort of break the chicken and egg situation when it comes to introducing hydrogen solution in maritime environments. We are developing several kinds of projects, and one of the projects that I would like to show you and can be seen as also as an example of the way we work is Portugal. Where Portugal is a concept that we are developing as a zero-emission logistics solution for urban waters. Not only to introduce hydrogen as a maritime fuel, but also to really tackle an issue that a lot of inner cities are dealing with. And sorry, and that is the issue of cities that have to deal with, this growing logistical demand. The vans and the trucks are going in and out of the city, which comes with additional harmful emissions, which come with additional congestion, which comes with noise hindrance, and which comes with a lot of damage to infrastructure. And we know that there are several water-rich cities that have the canals available. So they're really excellently suited to be utilized by for last mile transportation. Because the city, take Amsterdam as an example. Amsterdam is trying to ban all the trucks. I mean, from 2025 towards 2030, all the trucks are not being allowed into the city center. And there are probably solutions out there for B2C logistics, like your DHL guy probably is able to use a bike to bring the package to your doorstep. But if we need to supply supermarkets, retail, other building materials, we need to also think of other solutions. And then there's a business opportunity for that, and we think we can really utilize the water to develop this solution. So yeah. And what we have done is to really create what we say the concept called Portigo, which is the zero logistical solution for urban waters. So we really have developed boats that tackle this issue, really designed for inner city transportation, with a design that is super efficient, because we know hydrogen is expensive. So if we want to do it right, it has to be the boat has to be as efficient as possible, and it has to be super flexible. And the interesting thing about hydrogen is that we don't have to reload that boat everywhere. We're not dependent on loading infrastructure everywhere. If you just take enough hydrogen on board, we can go the whole day through the canals of Amsterdam. Plus, we have the flexibility to dock this vessel anywhere. At the same time, we need to be competitive to the truck. So the boat itself needs to have the similar amount of cargo units that a regular truck can take on board as well. But with the solution that we have developed, it is also allows you to unload all the rolling carts in one go, where a truck can only do 3 or 2 at the same time, which gives us an advantage, of course, and makes up also for the time that we lose, by being forced to transfer from a truck to the water. So basically, what Portigo is, it's a plug-and-play solution for providers and for suppliers and logistic providers. And what we do, we have the zero-emission boats. We want to link those boats to hubs that are located near water already, and really work also with an integrated planning app to allow people to really book their cargo transportation, zero emission, into the inner city, and be a very competitive alternative for road transport. And at the same time, because that is what we are doing it for, to really stimulate the transition of the maritime sector. Because what we include here in the system, we include hydrogen, and we don't reinvent the wheel here. We make use of hydrogen and fuel cell technology solutions that are already developed for the trucking and the automotive industry, and of which we know that are safe and being heavily tested. And literally the only thing that we need to do is to marinize them, make sure that that they also work in the environment where it's on the water. And of course, we have to deal with the local authorities to make sure that everything gets approved and so on. Because one of the things that is also lacking in the maritime industry is that there's no legislation for hydrogen propulsion. So with this kind of project, we're also trying to lower that threshold by saying, well, we're using existing technology, we're just optimizing it for waterborne transport, and as such, we can be really competitive to other modes of transport. And we think that is really the essential step to make hydrogen effectively introduced as a competitive alternative to others. And we can't only wait until the technologies are there, because then it's going to take too long. And as such, with this kind of project, we hope to really accelerate the transition. And happy to discuss this with you, of course, over the next coming minutes.
Thank you so much, team. So let's start. Let's try first to understand what stage hydrogen is in those different fields. And for that, I will want to start with the knowledge around it, the lack of knowledge and understanding. Using hydrogen as an energy carrier, it's quite new. And since building a hydrogen economy is bringing a lot of parties from the production to the end user, many players are involved. And for that, I would like to, the first stage, it's convincing those different players that hydrogen is the solution. So I would like to start with you, Markus, why it's so important to do a test center to show the people why it's important to do this test center.
Yes, I think if we're looking back in the history, for example, the mobility sector, if we look at passenger cars or heavy-duty applications, since 1995 we had the technology, the conventional technologies is much better than actually it's much better than 1995. Of course, we have less carbon emissions per vehicle. But the other issue is that we have more vehicles now, and in some we have more carbon emissions than 1995, and that's the point that to do hydrogen projects, because hydrogen has the potential as energy carrier, as fuel to be used in not only as fuel in vehicles in the mobility. It has also the possibility to be used in the industry for the chemistry and so on, and it's a very flexible molecule, and that's the reason we see in hydrogen the possibility to rebuild our energy system to get rid of those carbon problems. But it's not only the carbon problems, also to get rid of pollutant emissions, for example, and environmental pollution of conventional technologies. And so this is our vision, and this is the point why we are doing research in the field of hydrogen, from the production till application. All these things have to be met, and that's our vision, and that's why we are doing this.
And by building a test center, you can prove that it works. And today we are in this phase where people need to understand that it really works. And
yes, of course, it's an issue. We have to make the technology better. We have lots of systems and technology that works in the hydrogen technology field. We have actually the technology, but it's too expensive, and we need better efficiencies and so on. And that's why we are doing research in this field, but not only in this field in our laboratory. That's also the point why we are doing projects like Hycenta. We're doing it in the real field. We need projects on the green field to build up hydrogen infrastructures, to build up prototypes and to get it, to develop it to serial production and so on. We have to put the technology on the road, and that is what we're doing in the laboratory and on the field.
Thank you. Team, could you give us some insight on when you're approaching maritime companies? What are they telling you how do they visualize hydrogen? What are they thinking about it?
Yes, of course. Well, the simple answer is, if you talk about hydrogen in the maritime sector and you talk to shipping companies, to say, yeah, we are doing our research. We hear everybody speaking about hydrogen, and we know something needs to be done there. But they also say, well, if we invest in hydrogen today, the life cycle of our ship is 25, 30 years. There's no infrastructure for hydrogen. So if we make the wrong choice, if we bet on hydrogen and it should have been batteries or it should have been ammonia, how are we going to solve this? Because we can't afford to invest in the technology now today that is on a no regret basis. So we need to think of incentives, and we need to think of other ways to help the maritime industry to invest in these kind of technologies. I mean, if you develop a new engine for a car, if BMW develops a new engine, they can sell, I don't know, 200, 300,000 amounts of these engines. So that's worth the R&D But if for a ship, they're almost all one-offs. So if you really have to invest in a new engine, you're doing 2-3 million investments for an engine that you're probably selling once or twice. So this is really like a big hurdle that we need to achieve, and we need more standardization, and we really need to work with other players along the value chain, such as cargo owners, who can really bear the cost of new technologies and also looking for these new technologies, to really work with them together and jointly try to find, business cases or niches where these kind of cross-sectoral collaborations would lead to stimulation of introduction of hydrogen solutions for the maritime sector.
Of course, the business case is a big issue, and I have been experimenting that through all Europe. It's really complicated to find a business case, and sometimes you need to think out of the box and try to combine things to create the market and to make a business case. Tim, can you explain us how do you see that and how you try to make a business case from it?
Yes, of course. For instance, one of the projects that we are also been working on is to develop a shipping company for the cargo transportation for inland vessels, where we also included a fast mover consuming good companies, in this case Nike, who really has a clear ambition. They say, our entire logistic process needs to become zero emission in 2025. That's our mission. But if we do that over road, we're not going to get there. If we do it over water, it's probably per containerized, per let's say container shipped, it's less polluting, but it's not zero emission. So working from that ambition and then working our way back also to the shipping company, saying, well, if your customer basically wants this, you don't have the ships available, but if we can bring them together, and if your customer is able to give you a, let's say, instead of a 3-month contract, gives you a 10-year contract to do that, and in return you are developing hydrogen powered ships, or then suddenly there is a business case, and with this kind of starting point, then suddenly fuel station providers or developers, they suddenly become interested as well, because adding one ship on a certain route to their as one of their customers is almost the equivalent of 200 cars a day for a hydrogen fuel cell station, hydrogen fueling station. So basically, slowly we're building this case, and as of a result, one of these companies from next year on is going to ship containers for Nike between Rotterdam and Antwerp on an inland vessel, on an inland route, on a fixed route with hydrogen supply on both ends. And this way we create the business case. And on the other hand, we see other shipping companies then now saying, hey, wait, the infrastructure is there. For us, that might also be an interesting case. Or other cargo owners that say, hey, this ship is there. Can we also make use of your ship to also meet our own, our sustainability goals? And then we are slowly creating a market, maybe creating a market for a second ship, creating a market for competitors to enter the sector. And this is how we would like to, how we try to achieve that.
Of course, and it's possible because in the shipping industry you have a big amount of hydrogen which is used. Is it not more complicated, Markus, for you in your industry because it's less hydrogen, so to make the business case is more difficult?
Yes, of course, it's very difficult, especially in that phases where these projects are done, of course, because it says prototype status. But and the mid-term or long-term view, we have to include also other applications, not only the snowmobiles, of course, but we have to think about ski regions. We have tractors, we have snow groomers. Perhaps we have other passenger cars, for example, of the operator of the ski regions, and other applications near to this region. And these applications have to be combined, and then we have the possibility to get it in an economic phase, I would say. And one point also is the design of the infrastructure. it's very important to be flexible with respect to hydrogen production rate, because in the first stage we also have we only have 2 vehicles. In the second stage, perhaps 5, 6, 9 vehicles and so on, and in the third phase we have also, for example, passenger cars or high snow groomers, and it's necessary to have an infrastructure that can be modular, grow with the application and the vehicle number, so that we have a high utilization of the electrolyzer system and the infrastructure itself, because a higher utilization is needed to get it in an economic operating mode. And this infrastructure was at Hycenta, for example, was designed in such a modular way. It's a container design, and this modularity is also, you can put a second container, you can put electrolyzer modules in it. Also, the electrolyzer technology is very important. In that case, we have a AEM technology, which has, of course, advantages in terms of cost compared, for example, of PEM electrolyzers, and these things have to be taken into account, and then we will get into an economic and operation in the future.
Really interesting. And what is really interesting also with hydrogen is like you can adapt existing component and existing technology. And I would like to speak and go a little bit deeper in the technology with Xiaoxiao and the combustion turbine. How can we adapt an existing combustion gas turbine within hydrogen?
So we know that for gas turbine, there are mainly 3 components: the compressor, which brings the pressure of the air up, and also the temperature. And then we burn the fuel in the combustor, and then we the air is moved to turbine to drive the whole shaft, so that the compressor get the power. Also, we get the propulsion power for the aircraft. So when we switch from jet fuel to hydrogen, the biggest change is obviously going to be combustor, where we need to consider about, fuel system. The sort of feeding will be different in the sense that the amount of fuel used at different emission levels will be changed. And also we have to consider about the properties of hydrogen, the fact that it is easier to leak, for example, so that the sort of isolation will be different. And also the fact that we are storing it in the aircraft as a liquid fuel, so we have to find ways to convert it to gaseous before it enters the combustor. And in terms of the combustor itself, well, generally the combustor will look similar, but the temperature might be different. So we have to consider if the material has to be changed or not. And also downstream, the turbine. For example, if there is hydrogen that is not burnt and moved and flows through turbine, will that have an impact on the material? And also, after burning, we only get a large amount of water with hydrogen combustion, whereas in hydrocarbon fuels, you get CO2 and water. So the water content is increased. Will that have an effect on the material of the turbine? So these are all what we need to think about when we're trying to get a retrofit or doing changes to the gas turbine.
Really interesting, but we can see that it's completely possible and that it's way more economical than changing the whole system. Now to help the hydrogen economy growing, it needs to be support on the OpEx side, like on the use case. Can we have some insights from all your industry on the role of the regulation? Let's start with Tim, perhaps.
Sorry, could you repeat the
role of the regulation? How the regulation can help with the regulation, and what would you like to see?
Yeah, well, the issue with the maritime sector is that there is no regulation. There's nothing. Basically, after 8 or 9 years, finally, there's regulation for LNG, which is considered, let's call it a mediocre fuel. So as a sort of a transition fuel from fossil towards renewables, and actually, but it's not on the pathway to renewables. But it took the maritime industry, it took IMO almost 9 years to get regulation there. So if we are waiting for official regulation, we have to wait another 10 years before hydrogen is officially there. So that's going to be difficult. So we need to think along different kind of lines. And I think the best way is to lead by example, but it is doing it and proving that with the exceptions that are there, making use of the trajectories that have been set, have been taken for LNG, and say, well, hydrogen is in the same ballpark. We have the same kind of safety measures. We apply safety measures from the automotive industry, who are way more strict than for the maritime sector. I think that is the way forward, because in my view, regulations always come afterwards. I mean, I've never seen regulations coming before a technology was there. I mean, first you get a solution and then you get regulations. So we need to, be developing ourselves in order to get regulation there, and we can't reverse it.
Of course. And things in the airplane industry, it's quite different now, because there are many goals, and the goals are really high. So Xiaoxiao, what do you think about what will happen in the industry?
Yeah, I mean, when we started the project, there wasn't so much interest in hydrogen, but within the next, in these 2 years, the interest just exploded, and everyone is asking for hydrogen projects. And I think from the legislation perspective, I think that they find out that in order to achieve this ambitious target, we have to have some radical changes, including changing the fuel. So that is good for us. And in the project, we actually have a work package that work in the economical work package that we work on different scenarios of, if there is taxation for CO2 and how much is it, and for different fuel prices. I also think that not only legislation, but also fuel prices is also going to sort of influence the people's enthusiasm in one of the fuels. So, and we have legislation bodies that closely work with us, trying to see our development and to trying to helping or shaping doing the roadmap for allowing more alternative fuels, including hydrogen, to be considered.
What about you, Markus? When we are talking about the Alps, so when we are talking about beautiful landscape like this, do you have like local incentive that can push the development of hydrogen?
Yes, of course. Funding in that phase are very important for such hydrogen project as we do it in Hycenta, for example, because you have risks, you have technology risks and so on, and also if you have to win the ski region operator, for example, it's necessary that he has not to pay the fee, of course, for such a technology. So funding of such implementing project is, in that case, in these years, is very important, I would say. Funding in of course, projects which are developing specific technologies in the hydrogen technology field that are necessary to get the technology cheaper, to get it better concerning efficiency and so on. It's important. And it's also important for operators of facilities, for example, for electrolysis facilities, that we have some advantages, for example, for the costs of electricity. If we pay electricity, we have to pay a lot of taxes and so on. And in Austria, actually, there are some we have with electrolyzers we are free from some taxes for the electricity, and so it is possible to get lower OPEX, for example, and such fundings are needed, and that's the funding side and the OPEX and CAPEX side, and the other side is the approval of, for example, hydrogen infrastructures in the field. That there are a lot of hints that have to be taken, and a lot of, I would say, lacks in the regulation of, for example, hydrogen infrastructure approval for operation. So we have a lot to do.
And can you just explain us a little bit how does your project work? So you have solar panel and you are not connected on the grid and so that make it also easy to make the business.
Yeah, in that case, it's also connected to the grid to have a backup if the solar if the solar energy is too less. We have a large hydrogen storage, and so a large energy storage, and the facility is designed to meet I would say the most days the hydrogen demand with direct PV production. But there can be days where we need the electricity from the grid, and then we have to pay the normal electricity price that is actually with our facility for hydrogen production.
Thank you. Team, how is organized your project? How do you think about building the whole value chain when you are looking at project?
I think you answered already a little bit in your question. I think we have to look at the entire value chain, and we have to establish cross-sectoral collaborations in order to get there. I mean, because we have to make sure that there are companies or players involved who can bear the cost more easily. And then going back to the Nike example, if Nike would be shipping their goods inland on water on hydrogen propelled ship, it probably will increase the cost of their shoe or their sock with 0.0001 cent. Where it would, for the shipping company to do that, it would increase their operational cost by 50%. So you have to have the conversation with the multiple stakeholders to understand and help them to understand the two-way road that is there, that the joint, the 1 + 1 is 3 kind of an attitude. And that's basically the role that we like to play, and that we play is to really bring technology operators and end users together and jointly establish this business case. And I think to speed up, to accelerate the transition, I think that is the way forward.
Okay. And do you think, like, even if they are not forced to with the regulation, like we just spoke, there are no regulation that force them, they will put this transition and pay the cost of it? Do you think that you can convince them? What are the arguments for them to make this transition?
Yeah, I think for a company like Nike, I mean, they present themselves already as a sustainable company. So the more they are able to present themselves as a sustainable company, it's at the end of the day they sell more stuff because people want to be associated with this. So it's business. At the end of the day, it's still business.
Of course, but the customer, he wants to pay this extra cost of delivery, because at the end is the end customer who will pay it, or it will need to be assumed by the delivery company.
Well, I think the additional cost for the customer is very low, because the price increase of this kind of let's say, call it a shoe or a sock is literally just a few cents. So they probably won't even notice. And that is the funny thing, where a shipping company, they literally is the difference between going bankrupt or staying alive with making this kind of decision, and they have to invest in it, and the end consumer is profiting from it. So that is sort of a disbalance, that if we can solve that, because I agree, nobody wants to pay twice the amount for their shoes, because then you probably don't have a sale. But the difference is so marginal for such companies that it's very doable.
Interesting. And what about Xiaoxiao in the aviation industry? It's the same issue. Who will pay the cost of this transition?
Yeah, I mean, imagine that the aircraft company, the airlines, they have to pay thousands of millions of dollars trying to change from the current aircraft to a hydrogen aircraft. So they will just increase the ticket of flight, and people would not like that. So I guess from our perspective, that's one of the biggest hurdles that's stopping us from switching to hydrogen. Currently, not only the fuel production, also this building up this infrastructure and trying to have radical changes in aircraft. All those costs are very high, unless we have a really critical sort of let's say legislation also that's forcing us to change. Otherwise, not many people would like to pay for the change. So that's very challenging.
So we can really see the difference between the aviation and the maritime industry, and this is really really interesting. So let's see if we have a few questions. I think there are a few questions. This was a question: what are looking at infrastructure of transport and storing hydrogen at the airport? So this is a question for you, Xiaoxiao. How to build the infrastructure directly?
Well, we have colleagues looking at this perspective. I'm not the expert, but this is certainly looked at. I'm not able to give you an answer right now, but well, if someone could, who asked a question, that who contact me and who is interested in this, we can discuss later.
Of course. And something really interesting also, I think it's, you look at combustion engine in this aircraft, and why aren't you looking at technology like fuel cell?
Well, as I said, fuel cell has the factor that the weight is too high for long range. You cannot afford to have such a big sort of component on the aircraft with so many accessories and so on. And also that will require even more radical changes to the engine. But this is certainly feasible if we are concerning, for example, urban type of small aircraft or short ranged. So it's not, actually, it's one of the topics that is very hot now. The Zero-Avia company has demonstrated it's feasible with very small aircraft.
Okay, and what about in the maritime industry? Are you looking for like cheaper solution, like replacing a combustion engine or fuel cell ships?
Is that still a question for me?
This is for team in the maritime industry. Like, what are looking the customers for, like combustion engine or fuel cell boats?
Oh, yeah, sorry, I thought it was for aviation as well. Sorry.
No.
No, it's. I think for the maritime industry, we have to look at both, especially also again because of the lifetime of a ship. A ship that was built 2 years ago, it's going to be out there for 25 years probably in the Western world, and then maybe even for another 20 years in other locations in the world. So that means that 25 to sometimes even 50 years, these ships are going to be out there. So we also have to look at retrofitting existing ships, finding solutions to retrofit these kind of ships to adapt to newer kind of fuels. And of course, if we start tomorrow, then new builds have to be embedded with the latest technology. And I would say that would be fuel cell technology and not combustion. But maritime sector needs both.
Of course, for the transition, it needs to
Absolutely.
have.
Yeah.
And for the both of you, this question, it's not pushing the problem also by the NOx issues that's creating this combustion engine?
Yeah, it's a tricky one. I mean, actually, pure hydrogen in a combustion engine, it works. But if you want to go, let's say, from Rotterdam to Shanghai, you're probably not going to reach Shanghai because you can't take enough hydrogen on board. So you need to think of hydrogen compounds such as ammonia or LOHCs or maybe solid form, and that indeed comes with NOx or these kind of fumes or emissions. So there's a technology challenge there to mitigate that. But I think as long as we're on the pathway towards making use of renewable energy to produce those kind of fuels, I think that is a realistic pathway.
Okay, and on the technical aspect, Xiao, how are we reducing NOx? How are we avoiding NOx?
That will be quite complicated to explain. I'm not sure it will be. We will have the time to do this, but essentially we try to reduce the temperature of the flame. That's it, or reduce temperature of combustion. That's it.
Hi, everyone. Thank you so much. I am jumping in because we have our next session starting soon. So I just wanted to maybe ask for a final comment from everyone and then thank you again. So yeah, just maybe final statement. We could go on forever, right?
What are you thinking of all that? Thank you so much for inviting me and for moderating this session. It was really interesting to see the difference between all this industry and even industry that we don't even think about, like you are doing, Markus. And yeah, thank you so much. If you want to say something to finish.
Yeah, thank you. Nice discussion, and yeah, that's from my side. Thank you very much.
Yeah, thank you from my side too. That I'm going to broaden my eyes even wider to look at more industrial applications than what I'm looking at now. So very good opportunity. Thank you.
Yeah, thank you as well. And if you're interested in learning more or collaboration or thinking of projects, drop me an email. You can find it on our website, and otherwise maybe through the organization. And always open to have a discussion.
Thank you. Bye-bye.
Okay. Bye.
Thank you.
Bye-bye.